This all video belongs to the YouTube channel FFBMD, Fake Fashion Behind the Movie and Dance Show. Energy is stored in a charged conductor or a capacitor. In charging a conductor, work has to be done against the force of repulsion by the charge already present on it. This work is stored as potential energy in the electric field of the conductor. Suppose a conductor of capacity C is charged to a potential V0 or V0, giving charge Q0 on it. The potential of the conductor when during charging the charge on it was Q less than Q0 is V equals to Q by C. Now work done in bringing a small charge dq at this potential is dW equals to V into dq equals to Q by C into dq. Hence total work done in charging it from 0 to Q0 is W equals to integration 0 to Q0 dW equals to integration 0 to Q0 Q by C into dq equals to Q0 square by 2C. This work is stored as the potential energy, hence U equals to 1 by 2 Q0 square by C or 1 by 2 C square V0 square by C equals to 1 by 2 C V0 square, since Q0 equals to C V0, or U equals to 1 by 2 Q0 V0 into V0 square equals to 1 by 2 Q0 V0, since C equals to Q0 by V0. So finally we have three formula for potential energy given by U equals to 1 by 2 Q0 square by C or U equals to 1 by 2 C V0 square or U equals to 1 by 2 Q0 V0. In general, if a conductor of capacity C is charged to a potential V by giving it a charge Q, then we write the formula as U equals to Q square by 2C equals to 1 by 2 QV or equals to 1 by 2 CV square. NCERT sharing of charge, a redistribution of charge. Consider two spherical conductors separated far apart so that charge on one does not affect the potential of other. R1 and R2 are their radii. Q1 and Q2 are charged on them, and C1 and C2 are their capacitances, and V1 and V2 are their potential respectively. So we have Q1 equals to C1 V1 and Q2 equals to C2 V2 with Q equals to Q1 plus Q2 for both body or system, and C equals to C1 plus C2, where Q and C are total charge and capacitance of the system respectively. Now if they are connected through a wire, charge will flow from conductor at higher potential to that at lower potential till both acquire some potential given by V equals to Q1 plus Q2 by C1 plus C2 equal to C1 V1 plus C2 V2 by C1 plus C2, or equals to 4 pi epsilon naught R1 V1 plus 4 pi epsilon naught R2 V2 divided by 4 pi epsilon naught R1 plus 4 pi epsilon naught R2 equals to R1 V1 plus R2 V2 by R1 plus R2. And Q1 dash, note we have C1 equals to Q1 dash by V and C2 equals to Q2 dash by V. Hence C1 plus C2 equals to Q1 dash by V plus Q2 dash by V, or Q1 dash plus Q2 dash by V. Hence V equals to Q1 dash plus Q2 dash by C1 plus C2 equals to Q1 plus Q2 by C1 plus C2. since q1 dash plus q2 dash equals to q1 plus q2 from the conservation of charge. If q1 dash and q2 dash are the charge on the two conductor, after sharing them, we have q1 dash equals to c1v and q2 dash equals to c2v, with q1 dash plus q2 dash equals to q1 plus q2 equals to q, total charge. Hence q1 dash by q2 dash equals to c1v by c2v equals to c1 by c2 equals to 4 pi epsilon naught r1 by 4 pi epsilon naught r2 equals to r1 by r2. From 1 q1 dash by q2 dash equals to c1 by c2. This implies q1 dash by q2 dash plus 1 equals to c1 by c2 plus 1. This implies q1 dash plus q2 dash by q2 dash equal to c1 plus c2 by c2. This implies q2 dash by q equals to c2 by c1 plus c2. Hence q2 dash equals to c2 by c1 plus c2 into q equals to 4 pi epsilon naught r2 by 4 pi epsilon naught r1 plus 4 pi epsilon naught r2 into q. This implies q2 dash equals to r2 by r1 plus r2 into q. Similarly, we can calculate q1 dash equals to c1 by c1 plus c2 into q equals to r1 by r1 plus r2 into q. Second, common potential after sharing. We have V equals to q1 dash by c1 equals to q2 dash by c2 equals to q1 plus q2 by c1 plus c2 equals to r1 v1 plus r2 v2 by r1 plus r2 equals to c1 v1 plus c2 v2 by c1 plus c2. B में energy loss due to sharing. The electric potential energy stored in the system before charging ui equals to 1 by 2 c1 v1 square plus 1 by 2 c2 v2 square, and the electric potential energy stored in the system after sharing, we have uf equals to 1 by 2 c1 plus c2 into v square equals to 1 by 2 into c1 plus c2 into c1 v1 plus c2 v2 by c1 plus c2 का whole square equals to 1 by 2 into c1 v1 plus c2 v2 का whole square by c1 plus c2. So change in energy delta U equals to uf minus ui. Putting the value of uf minus ui and solving, finally we get minus of c1 c2 by 2 into c1 plus c2 into v1 minus v2 to the power 2 or whole square, as c1 and c2 and v1 and v2 का whole square is always positive. So from above it is clear that change in electrostatic energy is negative, that is final energy is less than initial energy. This means uf is less than ui, so there is a loss of energy due to sharing, and the magnitude of energy loss is given by delta U equals to c1 c2 by 2 into c1 plus c2 into v1 minus v2 to the whole square. This energy loss appears at heating, lighting and sound of charging across through the wires.